Hey y'all, it's Miss Reeb. Happy Friday. I wanted to start today by challenging you with this kindness challenge that I saw. So, a lot of your parents or grandparents or whoever it is that you're living with, they're really stressed out right now, even if they're not letting you see it. And so, I'd like to challenge you to go up to one of them today and ask them what their least favorite chore is, and then do it for them and see the way that it lights up their face and it makes their day and it makes them feel good. Doing kind things for people also makes you feel good. So give that a try, and let's get started on today's lesson. So today's going to be a review of the Pythagorean theorem. We have already learned about it before, but this time we're learning about it in a slightly different context. So last time we learned about the Pythagorean theorem, we were talking about geometry. This time talking about it, we're talking about numbers and operations and how it works with squaring numbers and square roots. So let's check out these definitions from when we learned it before. The Pythagorean theorem is a squared plus b squared equals c squared. A and B represent the legs of the triangles, and C represents the hypotenuse. The hypotenuse is the longest side of the triangle. It is across from the 90-degree angle. This only works for right triangles, and our legs are the two shorter sides. They go on one side of the equation. Our hypotenuse is the longer side. It goes on the other side of the equation. So let's take a look at this problem on the board. I have a triangle. And this leg is 3, this leg is 4, and we are looking for the longer leg. So I'm going to say that this shortest leg is going to be A. This bottom leg is going to be B. And our X is going to be our C. So I'm going to first write the formula on the board. A squared plus B squared equals C squared. And I like to write the formula every single time because it gets the more you do it, the more it gets ingrained in your head. So our A is 3, so 3 squared plus our B is 4, so 4 squared equals C squared, because our X is C. Now, we are going to use our order of operations. So we need to find 3 squared, which is 3 times 3, which equals 9, plus 4 squared is 4 times 4, which is 16, equals C squared. And now on this side of the equation, we have 9 plus 16, which gives us 25. And now we have a number equals a variable squared. And this ties along with what we did yesterday, where the inverse of something squared is a square root. So we're going to take a square root of both sides. Now remember, taking a square root is figuring out what number times itself gives you the number under the radical. In this case, it's 5, because I know that 5 times 5 is 25. So the square root of 25 is 5. And the square root of C squared is just C. So our C is 5. So let's try another problem. This time, this leg is the square root of 20. This leg is 4. And this leg is X. The first thing I'm going to do is decide which of these is going to be which of my legs. So I see that this right here is my right angle, and the side opposite of the right angle is always my hypotenuse, which is C. Either of these legs could be A or B, it really doesn't matter. As long as your hypotenuse is C. So now I'm going to write down the formula. A squared plus B squared equals C squared. I'll plug in my values. So the square root of 20 squared plus 4 squared equals c squared. Remember how I said that the inverse operation of something squared is the square root? So if we were to take the square root of 20 squared, we would just get 20. Plus 4 times 4 is 16 equals c squared. 20 plus 16 is 36 equals c squared. And now we'll take a square root of both sides. And remember, a square root is what number times itself gives you what's under the radical. In this case, 6 times 6 is 36. So the square root of 36 is 6 equals c. So for this problem, it looks like I have my hypotenuse filled in. My hypotenuse is always going to be my c value. So 15 is my c value. On these legs, it really doesn't matter which one's A, which one's B. I'm going to keep this B because it's on the bottom, but it really doesn't matter. And that means that A is what we're looking for. So the first thing I'm going to do is write down my problem. A squared plus B squared equals c squared. My A is already here. So A squared plus my B is 12. 12 squared equals my C is 15. So 15 squared. And now what I need to do is multiply, because with our order of operations, our exponents come first. So this is going to be 12 times 12, which is 144. This one is 15 times 15, which is 225. And then I'll carry down my A squared. Now I want to get the variable by itself. So I need to subtract 144 from both sides because it is the inverse operation. So minus 144, minus 144. On this side, they cancel out. I end up with just A squared. On this side, I end up with 81. A squared equals 81. And now, to get this A by itself, I have to do the inverse operation of something squared, which is a square root. And the square root of 81, remember what number times itself gives you 81 is 9. So this value right here is 9. This last problem that we're going to do brings together a bunch of stuff that we've already learned. It has the Pythagorean theorem, it has using square roots, and it has rational approximation. So let's do this. The first thing I'm going to do is decide which variable is going to go with which piece. So this is my longest side. It's also across from my right angle. So this 11 is my C value. This 4, I like to say that the B is on the bottom, but you could say it's A if you want. It really doesn't matter. I'm going to say it's B. And this X is the value that we're looking for, and I'm going to call it A. So now I'm going to write my problem. A squared plus B squared equals C squared. My A value is what I'm looking for, so I'm going to leave it as A squared plus my B value is 4, so I'll plug in a 4. 4 squared equals, my C value is 11, so I'll plug in an 11 squared. Now because of PEMDAS, I need to solve what is 4 squared. That's 4 times 4, which is 16. What is 11 squared? Well, that's 11 times 11, which is 121. And I'll just carry down my a squared. Now, if I want to get this variable by itself, I need to move the 16 to the other side of the equation by doing the inverse operation. I'll subtract 16 from both sides. I end up with a squared equals 105. And now I need to take the square root of both sides to get this a by itself. So I end up with a equals, whoa, 105 is not a perfect square. So we need to do some rational approximation. I know that 105 is in between two perfect squares. We have 100 on this side, and we have 121 on this side. The square root of 100 is 10. The square root of 121 is 11. So I know that the square root of 105 is going to be somewhere in between 10 and 11. So what I'm going to do is guess and check some decimals to decide where it falls. I'm going to start with 105 is closer to 100, so I'll start with 10.3. I end up with 106.09, and I want to see, can I get any closer than this? Well, let's try something a little bit smaller since 106.09 is too high. Let's try 10.2. I ended up with 104.04. So of the two, which is closer, 106.09 or 104.04? This 104.04 is actually closer. So my answer is 10.2. So the square root of 105 is approximately 10.2. which is a number in between 10 and 11. So this value right here is approximately 10.2. And that's all that I have for you guys today. Go ahead and do your quizzes assignment. You can let me or Ms. Holmes know if you have any questions. You can shoot us an Edmodo message or an email. We would be more than happy to help you, set up a Zoom meeting with you, or just try to answer your questions over email. Either way, please reach out if you need any help, and you can do your quizzes and then your exit ticket on Flipgrid.